Anyway, so let's go ahead and get going. This is the example from yesterday. Um, the one up above, sorry, what I was trying to show you, is that we did finally prove that it was divergent. You guys said, hey, look, it goes down and then back up. Well, actually, no, down and then equal to, which technically, alternating series test, help me out. Condition number 2 is less than or equal to, right? Okay, less than or equal to, the n plus first term is less than or equal to the next term. So it was equal to for a bit, but eventually, well, no, actually, it was equal to for a bit, but then eventually it was greater than. And then remember, we're not necessarily looking at the signs because we're in the alternating series test, disregarding the alternator for steps 1 and 2, or for part 1, part 2 of the test. But we do see this increasing nature, and so some of you guys were like divergent, and I was like, yeah, but look, y, it's also just 1 over n, so of course it's divergent. You guys over here also saw that it went 1 to 1/4 to 1/3, so then down and then up and then down and then up and then down and then up. Yes, I realize. It is going to fail condition 1, condition 2. But I was curious if you could figure out another way to show it. I think, just kind of in further reflection, I think maybe the easiest way to show it would be to take this infinite series, which is a piecewise function, and literally make it the sum of 2 different series. Splitting up the first one with the second one, so I could go ahead and have this infinite series minus, what am I doing a minus?
Because they're all negative.
All of these ones would be negative, yeah, then I could do my 1/4 plus 1/16 plus 1/36. Now here's a bit of a struggle in that we can't just steal this guy because it's not 1 over n. If I was to make it as a series, it would be n equals 1 to infinity. That's 1 over 1, 1 over 3, 1 over 5. How do I make it such that I plug in 1, plug in 2, plug in 3, and get 1 and 3 and 5?
2 and minus 1.
I don't want the piecewise function. I could do 2n minus 1. 2 times n is always going to be even. 2 times 1, 2 times 2, 2 times 3. And so if I just take a 2n and add 1 or subtract 1, I'll get all the odds, because even minus 1 is an odd, even plus 1 is an odd. That's one of those back from sequences and pre-cal. So we could make this, let's see, that'd be 1 over 1, 1 over 3, 1 over 5, right? Then I could do minus, okay. Who's this guy? Is he divergent or convergent? Divergent, right? He's divergent. But how would you prove that?
Integral.
You could do integral tests. You would have to do like a little bit of a u prime, so it'd be 1/2 ln of u, 1/2 ln of 2n minus 1. But when you go to plug in infinity to ln, what's going to happen? Okay, so integral test. Or, I think to be honest, I would have done a limit comparison. Anybody else? With 1 over n. 1 over n diverges p series, because when I multiply, the n's are tied, the limit is a constant. What one does, the other does. Hopefully you guys are doing homework, so these tests are kind of ingrained a bit, even though we haven't had an endeavor quiz yet. These tests, fill in the blank, endeavor quiz before the next test. Check out the calendar. It's bound to be coming soon, because I think we only have we only have 5 sections, 9-1 to 9-5. But then coming back, we're in 9-5. Maybe we go to 9-6? Sorry, I was looking at algebra. They're in 9-4. Anyways, coming soon. Look at your calendar. Over here, though, wait a minute. We need 1 over 2 squared, 1 over 4 squared, 1 over 6 squared. How could I do that one? Does that look good?
Yeah.
2 squared, 4 squared, 6 squared, 8 squared. Cool. What's this one going to be? Oh, wait, that's 1 over 8n squared. Couldn't I make that 1/8 times 1 over n squared? What's this guy do? Converge by p series. P is equal to 2, because I can pull the constant now. What would be divergent minus convergent? Divergent. So I could prove it another way. Because think divergent is infinite, and infinite ever expanding minus a finite. The infinite will win. Does that make sense? Now, if it was divergent minus divergent, I'd be in some hot water, because it's like infinity minus infinity. Who's stronger? Do they cancel out? I don't know. That I couldn't say. But infinite minus finite, still infinite. But anyway, coming back. All that to say, did it work saying that this alternating series does in fact decrease, then increase, that it was divergent? Yes. So when you guys were saying, hey, step number 1 is the limit as n goes to infinity of either piece of my piecewise equal to 0. I don't know, we could list it all out. But was it equal to 0? Yes, that was okay. But where did this one fail? Step number 2. A sub n plus 1 was not always, that's bad, sorry. Was not always less than or equal to a sub n. Since it failed, then yes, I could say divergent. All I have to say, I was curious if you could think of another way of proving it, but both of those could have also been proven by, hey, it fails step number 2 for an alternating series, so yes, whenever you see it going down and then back up, for an alternating series, it's not strictly decreasing, yes, I can say it's divergent. Okay, those of you guys that are in the video with us, sorry you missed the beginning of class where I said that there are 2 kind of lengthy, could be way worse to be honest. A quick summary of a cautionary tale on the alternating series test. I'm going to go ahead and post these as PDFs in Google Classroom for you guys to read. Homework number 41. We'll debrief just a little bit on Monday. But because today's a minimum day, let's keep going to get, okay, here we go. Here we go. Don't wake up, Joe. I know, Joe. I'm so sorry. I don't know why you're so tired. You can be a little bit spaced out, just not totally knocked out. Here we go. Estimating alternating series. However, whoa. This doesn't just say estimating infinite series, right? Specifically estimating alternate. It sounds like alternate realities. I don't really want to go into that. Not really my forte, alternating. Although there was something interesting from some Columbia professor who's a string theorist who wrote some book about mind and matter. And he basically wrote a New York Times covered it or the Wall Street Journal. I was listening to a podcast from Albert Mohler. He's basically a president of a seminary who is very, very, very aware of the culture and works hard to be knowledgeable in what's going on in the culture and how we as Christians should knowledgeably be following world events and thinking about what it means for our worldview and the worldview of those around us. Anyway, super interesting. It's called The Briefing every day. And everything's been political about as far as like the impeachment trials and the caucuses and all sorts of stuff this week. But today he was finally able to get into like some of the like non-political stuff. Not non-political, but less political. So this doctor, I think it's Dr. Green. He said professor, but then later he said doctor. He watches his words very carefully, so it must be doctor too. String theorist, professor at Columbia, was talking about how a New York Times journalist who was covering the book, there are some things that are right or wrong. But in this day and age, it's becoming less and less possible for people to understand that. That wasn't the true quote, but that was the idea. And it was interesting because it's totally secular. I wouldn't say it's totally secular. At one point, he brought up the majesty of religion in another quote in the book. But he said that his scientist friends who are like basing or judging religion based on its veracity, based on its truthfulness. He's like, that's not the right ruler to judge it by. He's basically saying the Bible doesn't need to be true in order to appreciate it, basically saying it's not true. And this podcast guy is basically saying, like the Bible says in 1 Corinthians, if Jesus is not literally, truthfully, in all space and time, historically alive from the dead, our entire religion is in vain. However, I'll have to say this guy is not necessarily, in my opinion, bless you, someone to be completely trusted, but it does seem to be an interesting premise that he's putting in the book about mind and matter, and he, as a string theorist, is saying like, okay, hold on, there are some rights and wrongs, some truths, but in this day and age, it's becoming less and less possible for people to actually agree or live like or think like that is true, and he's seeing it in the college students that he is getting, that everything is subjective, and that is a dangerous premise to live life on. Don't know how that came up. Oh, alternate realities, because the string theorist is talking about alternate dimensions and what life could look like in different universes. And anyway, that was brought up just a little bit. I heard string theory and I was like, ooh, and then it turned into something else. But alternate alternating. We're not doing alternate realities, we're doing alternating. Alternating series estimation theorem. We can estimate, and that's kind of like a ding, 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 ding moment, because up until this point, the only thing that we've been able to even talk about the actual sum of are two series. Which ones? Geo and telescoping. Oh, well, convergent telescoping. If it's divergent, that's not going to help. But convergent telescoping. And just because we have pluses and minuses with parentheses does not mean it's telescoping. We saw one yesterday that was alternating and not telescoping. I think it was the piecewise one. But now we have a way for alternating series. If they converge, if they diverge, we'll forget it. Why estimate a divergent sum? Because there isn't a sum. But if it's a convergent alternating series, we have a way to estimate. So, if the alternating series converges, ooh, wait a minute, hold on, alternating, this is an error thing. If the alternating series converges, the truncation error, wait a minute, this is something we've talked about with the AP test last year with grading. Truncated. What you do with your decimal answers, truncated. What you do with your decimal answers. They say that you can have 3 decimals either rounded or truncated. What does that mean?
So truncated is like you don't round basically.
You just take the 3 as they are. Rounded or truncated. They will take the 3 decimals. Why? Because some people might write 5 decimals and don't round because they're writing extra. And they're like, no, we'll count it. You can give more than 3 decimals. You don't have to round. That's the one exception as far as the numeric answers on the FRQs. Rounded or truncated. Just cut it off and just look at the 3, or write extra and we're only looking at these 3. So truncated, cutting it off. What does truncation have to do with series? The truncation error for the nth partial sum. Oh wait, nth partial sum. Partial sum is a sum of only part of the series. True? 10th partial sum. Do you remember from pre-cal coverage? 10th partial sum is the sum of how many terms? It's easy. 10. Yeah. The 100th partial sum is the sum of how many terms? 100. Exactly. So if you're taking the 10th partial sum or the 100th partial sum or you're truncating the series. Why? You're ignoring the 11th and 12th and 13th, or you're ignoring the 101st and 102nd and 103rd. You're ignoring the ... So truncated, you're only taking a certain number of terms, right? So truncation error is how far off are you if you take 100 terms? If it's convergent, maybe not that far. Because even though there are infinitely many terms, all of those terms are approaching 0, remember, of any convergent. There are some approaching 0 of divergent too. But those terms are getting smaller and smaller and smaller. Just think the decimals are getting 0.00000000. Maybe you're not that far off if you have the first 10 or 20 or 50 or 100. The truncation error for the nth partial sum is less than, now it says less than or equal to, less than, we're going to put a less than or equal to kind of just to save our butts, but less than the a sub n plus first term. Thinking alternating the a sub n plus first term, remember whatever that term is then going to be subtracted and then added and then subtracted, or vice versa, subtracted, added. So whatever that term is, it's going to kind of be broken down over the next infinitely many terms. Meaning, if an alternating series converges, the error is in estimating the sum using n terms is less than the n plus first term. Can you guys go ahead and put parentheses around that n plus first? It's very improper the way it's written. N plus first term. Got it. So R sub n, remainder truncation error is how far off you are between the actual sum. S is the infinite sum, the entire infinite series. S sub n is the partial sum, only using n terms, will be less than or equal to a sub n plus 1. All of a sudden, we now have an idea for alternating series, at least, of, okay, if we take the first 5 terms, 10 terms, 100 terms, we will know how far off we are. No, we will have a bound of how far off we are. We will be somewhere in between the absolute value, so the positive and negative error of whatever that n plus first term is. You guys can read through a little bit more of the blah, 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 blah. They're just kind of talking about with an alternating series, you're going to add a number, so you're going to go a little bit as you do the nth partial sum. So like the 10th to the 11th is going to jump up a little bit by adding, and then the 12th is going to jump down a little bit by subtracting, and then it's going to jump and jump. It's kind of talking about this whole jumping past the sum every time. But the distance and the jumps will keep on decreasing. because of that whole idea of all the terms approaching zero. And so another way of putting it is the error, the absolute value of the remainder, is less than or equal to the magnitude of the first neglected term. It's another nice way of putting it. The first neglected term. Bottom line, you get an idea of how close you are to the actual sum without ever knowing it. So here's the struggle. You're going to know how far off you are, or at least a bound or a range of how far off you are, but you still don't actually know the sum. You just know how far off. And if that how far off is 0.00000000, well, I mean, is that enough? In many cases, yes. In many cases, yes. Especially if you guys are thinking about programming and programming your calculators. If there are these power series that are coming, infinite series that somehow are able to approximate any algebraic, transcendental, trigonometric function with like one power series formula, super interesting, we're getting there. How many decimals of accuracy, degrees of accuracy, do you actually need for the calculator? Well, only however many decimals show up. If you were to see the entire thing, it's going to go off and it's going to diverge. It's going to be different than the exact algebraic answer. But in the calculator, it's going to be close enough for you because the decimals will match up to a certain point. Except for, actually, I would love to show this to you. How much time do we have? Let's not. On Monday, remind me, there was a really interesting A-B integral that I plugged in that I thought would have been way, way closer. Basically, it was a 0.666666667. It was like a 40 thirds or something where, well, that wasn't right, maybe a 20 thirds. The actual algebraic, solving the antiderivative f of b minus f of a, we were just solving a definite integral, would have been 20 thirds. That 2/3 should have been 0.6666666, but when we used the integration feature on the calculator, it was like 0.66. I think it only got 3 or 4 before it went way off, and I was like, I have never seen it be that bad. Like, we've seen things that were supposed to be 0 be like times 10 to the negative 20th with 0.9999. Like, we've seen weird things like that, but this one, for some reason, I was like, why is it so far off? And it was the same example we did last year. And it wasn't just my computer version of a TI that was doing it, it was theirs too. Anyway, I meant to ask you guys about it. Because I was like, I don't know, I haven't seen the calculator be that far off in a while. But, we'll get back to that when I have time to pull up the notes and show you on Monday. What do we got? A convergent alternating series of the simple harmonic motion one, the simple harmonic 1 over n, the divergent 1 over n with an alternator, which means it's convergent, although conditionally. And it says, estimate, not find, estimate the sum of the series by taking the first 5 terms. Oh, okay, so S sub 5 equals, isn't it just the ones that they have there with one more? Okay, life starts to get a little bit exciting right about now because we're using equals because this is a partial sum, this is not the infinite sum. We're going to use it to approximate, I believe in a second, we haven't kept reading the question. But how do you figure out what this is? Yeah, but how do you add it? Common denominator. What's your common denominator?
60.
5 factorial. Right? 5 times 4 times 3 times 2 times 1. Well, that's fun. 60. Good, lady. So we have 60 over 60 minus 30 over 60 plus 20 over 60 minus 15 over 60 plus 12 over 60. That's interesting. Equals. We have 30, we have 50, we have 35. Oops. Yeah. You guys double checking me? And then we have 47. Yeah. Perfect. Love when we can play with numerical stuff. And you guys are actually keeping track, unlike most of my classes. Okay. No, really, people are so lazy with numbers anymore, and it's like that's where it's fun. I mean, not for all people. How accurate is this statement? Or sorry, is this estimate? Not the S sub 6. Find the first neglected term. Yeah? We did the a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. What's a sub 6? We'll know how far off. We'll know the bound. So a sub 6 is just good call. It is a negative 1/6. That's the point I care about. Did you guys catch the magnitude of the first neglected term? 1/6. How accurate is this estimate? Couldn't we say something to the extent of S sub 5, S sub 5, which equals 47 over 60, is approximately my infinite sum from n equals 1 to infinity of negative 1 to the n plus 1 all over n, within 1/6 of the. Now that's kind of the wording in that this 47 over 60 is within 1/6 of the actual. We can know how close we are, even though we don't know exactly where it was. And actually, here's, since we're talking about the veracity of the Bible, the historical truth of the Bible. When I spent a semester in Israel, there were multiple places where my professors who had been living in and going to Hebrew University, as far as that's the big like national university there in Jerusalem, and it's not like a Christian university, but they had just been living in Israel for a long time, and there were different places where they would be like, we are within a stone's throw of, meaning throw a stone, throw a stone, throw a stone, based on the facts of exactly what was put into the biblical record, and like different people like Josephus and other historians, Roman and Jewish and otherwise back in the day, they could say where we are standing is within a stone's throw of. It's here. You're looking at the actual place, just we can't actually like stand and say this is the exact spot. We just know based on the biblical record this is within a stone's throw. This kind of always reminds me of that in the sense of we're within a 1/6 row of the actual answer, whatever it may be. How could you make it better? S sub 6. How could you make it better? S sub 7. How could you make it better? Okay, this could go on forever. How many, ooh, this is where it gets really interesting. How many terms would we need? What if you knew what degree of accuracy you needed? I know I'm using degree of accuracy and that's technically like a scientific thing, but the idea is, what would I need in order to get it within 0.005, 2 decimal places accuracy of the actual sum? What if you knew what you needed? How many terms would you need to go to? What are you doing, Lorenzo? You're thinking up here and saying stuff out loud. No, what are you thinking? Make it a fraction. Ooh, that's nice. So we know it needs to be 0.00. Wait, it. Who's it? The next neglected term, right? The magnitude of the next neglected term needs to be less than or equal to, right? It will be within 0.005. Now, does that mean that the next neglected term is equal to exactly this? No. I just need to see, okay, how many do I need to get to be within this range? So we can think of the absolute value, if that helps, the absolute value of the a sub n plus 1, which is the same thing as 1 over n plus 1. Hey, do I have an expression that I can now work with? Yeah. So I can think 1 over n plus 1, whether he's positive or whether he's negative, has to somehow be between point. Now, Lainey said make it a fraction because, well, it's a fraction. So 5 over 10 hundredths thousandths. Wait, doesn't 5 over 1,000 reduce? Yeah, to be 1 over 200. So I have positive 1 over 200 and negative 1 over 200, because as we've already seen, the negative 1/6, I care about the magnitude of how far off above or below. We're not doing above or below. We don't even know what it is. We just know the range. Remember, like my stone's throw in any direction. When, how do I do this?
Oh, it's just like the squeeze sign.
It's like the squeeze theorem, but I actually need to get to n.
And we can set them equal too.
Set them equal? Okay, but then just a warning, when you set them equal, it gets a little bit complicated as to the inequality, but we'll get there in a second, that's fine. So if I cross multiply, I have n plus 1 is equal to 200. I have n equal to 199. That's the answer?
It's the 100 term.
But what if it didn't work out nice and neatly and easily? What if I had like an ln of n plus 1 and it never actually equals 200? You guys realize that we would probably need to take whatever we get and then we'd have to solve it as a decimal and say, wait a minute, I need n to be a whole number. This is nice, this is neat, this is a whole number. But what if it was an ln of n that needed to equal 200? All of a sudden, e to both sides, well, that'd be an awful thing to do. What if I had e to the, I don't even know. Anyway, what if it was 199.672?
It's 200.
Would it be 200 or would it be 198? just double check with your inequality that you're right, whatever you end up choosing, if you have to round a decimal. Someone, we lost her.
Always using the.
But in this one, if I plug in 199, yes, 1 over 200 is less than or equal to, greater than or equal to, negative 1 over 200. So what do I need? I need 199 terms.
Always using the bigger term of 1. Like, you'll always have benefit because the more terms you have, the more accurate you get.
Yes, but if that was the case, then the AP would say, oh, you can answer with 5,000 every time and you're always good. They're going to ask you for the lowest, the least possible, how would they put that? The minimum value such that the error is within. Does that make sense?
But you can still, like, if you have a decimal, like 189.6 something.
Oh my god, dude.
Oh my gosh! Oh my psych! Ryan
Questions where kids have gotten stuck in the past and then we'll have to keep an eye on it. I don't think it was that easy. I don't have every single function in my head, that's the problem. But I know of very specific examples where kids got stuck and went the wrong way. So I'm just, what do you think we're doing in Go? Keep an eye on it. I'm just wondering. What approximate was that? This is just me putting in context what it means. So it would take 199 terms, like adding up 199 for us to be within 0.00. Is that cool? Yeah. Bye guys.
I did.